Hi, I'm Karynna, and today I'm going to walk through our attitude simulator. This is a tool that's available in our SAT Pro module, as it is specific to satellites. So I have a scenario set up here with just a default satellite. The body axes are being shown, and I have a camera or an imager with a small field of view that's just pointed fixed down to the surface of the Earth. So my camera, again, is just a rectangular 2x2 vertical by horizontal half angle sensor, and it's just fixed onto the body of my satellite. What I want to do is fly over these various cities on the eastern coast of the United States and use my camera to image or dwell on each of these cities for a specific amount of time so that I can image them and collect that imagery at my satellite's orbit. Within STK, we have the ability to target the different places with our satellite. So we're actually able to move our satellite's attitude so that it's able to target each of these different places. If I go into the properties of my satellite under basic attitude, you can see that I have these different attitude profiles under the multi-segment, and it allows me to specify the time intervals, the start and stop time, of where my camera is going to be pointing. So at certain times I have sun pointing, I have that default nadir pointing, and then I'm able to skip between each of the different places. So I can use that targeted pointing in order to really hone in on all those different places. But in this case, this is assuming a perfect pointing satellite. So if I animate through this, we'll kind of watch as our satellite jumps immediately or instantaneously from each of these different places. So you can see as it flies over Boston, it kind of jumps right over. It jumps over to Washington, D.C. I can also show our 2D map with the persistence of our sensor turned on, so you can kind of see how it's jumping to each of these different places in order to image them, which is good visualization. It allows us to analyze how long we're able to image each of these places, but it's not very realistic. In reality, we have a satellite. It's not able to just immediately change its attitude to image a different location. So what we can do is use our attitude simulator in order to specify an attitude control or feedback control of our satellite. So to open this up, I can right-click on a satellite, go to Satellite Attitude Simulator, and this is the properties window for our attitude simulator. So I can specify the start and stop time that I want to look at the analysis. I can define the epoch, and of course the initial conditions of our satellite, so the initial attitude that our satellite is beginning at. If I want, I can also add momentum bias if we may have spinning components within the satellite. In this case, I'm going to leave that disabled, and I'm going to click on configuration down here. Within the configuration, I have different areas where I can add a script or a function. In my case, I want to look at the simulation section because at each time step, I want to grab the reference axes of my perfect pointing satellite, and I'm going to use that to try to target my attitude simulated satellite. So based off of how my perfect pointing is pointed or oriented, I want to use that in my attitude simulated satellite to point to all of the different places in here. So what I've done is I've added a script within this simulation section. And just to show you guys what this script looks like really quickly, I'm going to go ahead and open it up in Notepad++. And basically all it is it's a VB script that specifies the inputs, the outputs, and then the actual user-defined section in here. So my inputs, I'm just taking the time, of course, the epoch, and the attitude of our perfect pointing satellite. So my reference source is this perfect pointing satellite, the one that I just showed in the 3D graphics window. And all I'm doing is a simple feedback control loop. So I'm pulling in those inputs, I am defining some arbitrary gain values, and then I'm applying a feedback control law. So pretty simple, straightforward feedback control, and then I'm outputting the torque. So at each time step, I'm going in and I'm inputting these parameters, and then I'm outputting the torque. And I'm going to use that to simulate our attitude-controlled satellite. So a couple other parameters that we can set in here is the numerical integration method. So this is just using the Runge-Kutta-Felberg integrator. I can specify the environments or the atmospheric density model that I want to use. Right now, I'm just going to stick to all of the defaults. And the important part is I want to output this file. So the output is just going to be an attitude file, so a .a file in STK. I'm going to check the use for attitude definition, which means that it's automatically going to push our attitude into our attitude simulated satellite. And then I'm just going to click run. For the purposes of this, I went ahead and ran this already. So let me just show you guys really quickly what's happening. If I go into the basic attitude section of my attitude simulated satellite, you can see right here, the override basic and target pointing attitude is enabled. And the file that it's reading from is that output from our attitude simulator. So the attitude simulator.a attitude file is what's being used for my attitude simulated satellite. So I'm going to go through and just animate this again. So we still have the blue as our perfect pointing, but now you guys can see as our perfect pointing is jumping instantaneously between these different places, the white is our attitude simulated satellite, and it actually has some of that overshoot, some of that dampening, and it's kind of passing over the place before it actually locks in on it. So I have that persistence on, which is what's showing the footprint of the sensor as it's flying overhead. So it looks a little messy. The persistence is just based off of the amount of time and how quickly I'm animating through. So we can see this visually in our 3D and 2D graphics windows. But another thing that we can pull up is a report on the Euler Angles, comparing our perfect pointing and our attitude simulated satellites. So if I go ahead and pull up this graph and kind of zoom in to the point where our satellite is changing its attitude to image all of these targets, I'm also just going to decrease the time step here. Let me zoom in even further. We can see the comparison between our perfect pointing. So that's looking at the pink, the yellow, and the blue. There's 6 different lines kind of all in this graph, so it's a little busy, but you can see that our perfect pointing actually follows this stepwise function where as it's changing its attitude and moving to different places, it's instantaneously jumping between all of those targets. And in comparison, our attitude simulated one has this overshoot that's going past the target and then kind of dampening out and also matching our perfect pointing. So this is just a way that users can add their own custom attitude control or their feedback control within the satellite's attitude through the attitude simulator. Thanks.